big part of this module is this plugin customization architecture. The big difference is that frameworks give you the possibility to customize them and upgrade them. We're going to implement a few plugins. First, for upgrading any unit, our clients, they can decide creating all of these additional functionalities without modifying the original framework code. This pattern is quite popular in this type of user-coupled architectures. We have some .NET specific logic for getting, if the test failed, it will populate this throw exception. This C# reflection allows us to get from a specific type or a specific method to get its attributes. Hi guys, greetings from Bulgaria, I am Anton, and this is the third video out of our Advanced Test Automation Framework course. We're going to discuss plugin architecture and customizations. If you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified when there are new videos. Also check the awesome Lambda test blog, because each week there are tons of new articles that can help you to become much better test automation engineer. In the links below you will find everything that you need, the links to the GitHub repos with all of the codes that I'm going to present. Also you will find the reference articles part of the Lambda test blog. I suggest to clone the repo with the code and check the code while watching the video. Also, you will find in the links some links to parts of the video. If you know something, you can skip it, or you can increase or decrease the speed of the video. So let's get started. Here is our course overview. I won't spend time again to discuss it, but I suggest to check all of the videos sequentially because they are interconnected. First, we defined the scope and the requirements, and then in the second module, we started to implement those requirements, building all of the web core components. And now we are going to upgrade that, bringing this plugin architecture using some advanced design patterns. I'm going to use some design patterns that we already covered in another course called Design Patterns in Test Automation. You will find links to it below. Of course, I'm going to refresh your memory and explain everything that you need to know. So in this particular module, first we're going to cover this plugin architecture and in many details we're going to see how to implement the observer design pattern, and we're going to extend an unit and after that some of the web component adapters so that we can, for example, highlight some of the elements while the test is playing. Also, we will scroll down to particular elements, and this will be incorporated in another new project that will be called Polaris Customizations. And a big part of this module is this plugin customization architecture is really important. This will upgrade our test automation library to a framework. The big difference is that frameworks give you the possibility to customize them and upgrade them, which is not always possible for many of the libraries. Also, I told you about it in the previous two modules, that the suggested approach of using the library and distributed it across your teams or users, if it's open source, is to use GitHub Git submodules. So we're going to start with that. I'm going to present to you a new repo where I implemented that. So then we'll proceed with discussing the observer pattern. We're going to implement a few plugins. First, for upgrading any unit, where we're going to control the browser locally using attributes like, for example, changing the browser, changing whether we want to reuse the browser or restart it every time or just on a failure. And then I'm going to explain and show you some other customizations that I created in this new project. So let's get started and let's begin with this Git Submodule architecture. So before we begin, again, I suggest to clone the repo. It's called Polaris White Test Framework. And as I explained last time, for each particular module out of the course, I created additional branch. So right now, for this particular module, you need to switch to this branch, plugin architecture and customizations here. And you will see the current version before we upgraded it later. And now the new repo that I created, it's called 𝑨𝒏𝒕𝒐𝒏 𝑨𝒏𝒈𝒄𝐫𝒐𝒗 system tests. Imagine that you have two teams. One of the teams is responsible for developing the framework. Many often this is the quality engineering team inside your organization, and maybe the core role of the QA architect. And then this framework should be used inside other teams like, I don't know, CRM or support system team or shopping cart team, etc. And all those teams probably they will have different repositories with different tests. It really depends how big your organization is, or whether the framework is open source or not. So inside this repo, here there will be two projects. One of them will be my tests, and then we'll have another folder for customizations. Anything from custom web components, new 𝐏𝐚𝐭, wait strategies, extensions to the driver adapters, we will discuss all of them, or different new plugins. And as you can see here, with this specific icon, this marks that I used the other repo here where my framework is a Git submodule. And let's find Git submodules here, this documentation. You can check it out. This is the original documentation of GitHub. So a Git submodule is a mechanism that allows you to incorporate and manage one or more Git repositories within another Git repository. And this is particularly useful for including external projects or libraries in your main project, while keeping them as separate repositories. This is our main goal. This will ease the update later of the framework. You can pick another version, etc. And of course, we'll have different branches and history and everything in different rules, maybe for pull requests. So yeah, while keeping them as separate repositories, each submodule maintains its own commit history. It can be developed independently, making it easier to manage complex projects within multiple dependencies. Each submodule is a separate Git repository with its own history and branches. The main repository tracks specific commits of the submodule, ensuring that it always points to a known state. Again, if we create another release of the framework, and if we use Git tags, this is the way how we develop, for example, my own 𝑨𝒏𝒕𝒐𝒏 framework, developed by 𝐼𝐡𝐚𝐭. So later, inside of our clients, they can decide which version of the framework they want to use as a submodule, right? And this is exactly what we are going to do. So I already initialized the project and I cloned it. So this is here, I cloned this 𝑨𝒏𝒕𝒐𝒏 framework system tests, right? And as you can see, we have two projects. I copied the project with our tests here, demo system tests, and I created one more project called 𝑨𝒏𝒕𝒐𝒏 which is not part of the original framework, right? And inside this folder framework here are basically the projects that are part of my original framework that I'm going to use as a submodule. Here it is. This is the folder. This is the folder of this 𝑨𝒏𝒕𝒐𝒏 system tests. And here I added this 𝑨𝒏𝒕𝒐𝒏 test framework as a submodule. At the moment when you add it as a submodule, it will just clone the repo. Of course, you can add it to another folder. This is not a problem. I opened the command prompt here inside this folder, and I want to show you the exact command how to do that, how to add it as a submodule. Use the git submodule add command to add the submodule. You need the URL, like I copied it here, of the repository you want to add, and the path where you want to place it within your main repository. Right now, I don't provide the path because I want it to be placed inside the main folder. I already did that. After that, after adding the submodule, you need to initialize and fetch its data. And you can do that with Git Submodule update init recursive. This will initialize and fetch its data. After that, it depends which version you want. There are different commands, but basically, I switch it to this particular, I switch the submodule or the Polaris framework to this particular branch. So you need to check out the particular branch that you want to use inside your project. After that, it's easy. If you use Visual Studio, it's relatively easy. Here, as you can see, we have multiple repositories at the bottom. Let me show you. Right here, you have icons. You have two repositories and multiple branches, and you can switch them. For example, when I click here, you can see that I see now that I have two. I have branches for Polaris White framework, and I can switch the branch for the current repo, which is Polaris White Test Framework System Tests. And the usual approach is that when you want to, this will ease the debugging inside the framework if you want to add new features or to fix something, but also, and this is how we actually configured our Beatrix framework, we have specific rules for making PRs. This means that you cannot just, place a commit inside the original framework, but instead you need to create a branch, then you need to create a PR, then someone needs to review it from the core maintenance, and then they need to merge it if everything is fine. But again, you are not obligated to create any PRs. You can just use the framework as it is. And the whole point of talking about plugin architecture and customizations is exactly about creating all of these additional functionalities without modifying the original framework code. So let's discuss that now. Let's discuss this plugin architecture. Again, we're going to base it on a pattern called Observer Design Pattern. And this pattern is quite popular in this type of 𝑨𝒏𝒕𝒐𝒏 architectures. And I'm going to present to you a version of it that you can implement in any popular programming language, object-oriented programming language. At least in C#, there are maybe at least 3 versions of it, how you can implement it easily. There are some built-in capabilities within the language, some interfaces and special classes. You can find an article of mine on Automate the Planet blog. Also, you can use event and delegates, but I will skip that because this is some kind of a specific for C#. For example, you don't have events in Java, at least not built in. And this is why I'm going to use a much simplified version to ease that job. So, the observer design pattern defines one-to-many dependency between objects, so that one-to-many dependency between objects, so that when one object changes the state, all of its dependents are notified and updated automatically. In our case, let me explain it within the framework. The thing that we want to do is that we want to extend NUnit and MSTest. For now, we'll just work with NUnit for simplicity. And we want to execute logic of every plugin without modifying the base class here every time. For example, if you want to add this new functionality for controlling the browser, I don't want to modify the base test, right? I want to create this 𝑨𝒏𝒕𝒐𝒏 architecture design without my base classes to know about the plugins. Later, we're going to upgrade that with allowing our tests to be executed in Lambda test. Then we'll have another plugin for example, marking whether the test has passed or failed. It's going to publish, for example, is going to publish some of the exceptions to the platform. For security reasons, we might want to download some of the videos from the cloud and save it somewhere else. Again, we're going to do that with some of these plugins. But again, there are many additions that can be added to our workflow, and we don't want to every time edit that. And we want to be able to do that outside of the framework, to allow the different teams the possibility to customize it without modifying the actual framework. Otherwise, one team can make the change and then break other teams, and we don't want to cause this type of regression. Or you don't want to edit your base test and then break 1000 tests, right? Basically, this allows you to send data to many other objects in a very efficient way. This happens through this plugin observer. As you can see, in our case, we want to execute logic before the test initialize, after the test initialize, before the class initialize, after the class initialize, before the test cleanup, after the test cleanup. Most of the plugins actually will execute logic just before the test initialize and after the test cleanup. This is the usual approach, but again, depends on the case. As you can see, we have a couple of classes here that are part of this particular relatively complex design pattern. We have the plugin observer, or usually this is called just observer, but I rename it to easily explain it. I call this plugin. And even in the pattern, in the original implementation, interfaces are needed for both, for the plugin observer and for this plugin execution engine. In the original pattern, this plugin execution engine is called execution subject. Again, to ease our job and to simplify it a little bit, I will use just base classes for that. I'm going to use the terms plugin and plugin execution engine because you can easily understand what they are going to do. And our base test, it won't know which plugins will be executed by the plugin execution engine. Instead, it will just use the plugin execution engine, and that's it. Later, in some of our specific tests, we are going to add the plugins to the plugin execution engine, but again, without modifying the base test class. That's it. Let's see it in action, and I'm sure that you will get it. The thing that we want to do before discussing now this local execution engine, let's see where our plugins needs to be placed. I'm going to place them inside this Polaris White core, inside the plugins namespace, right here, right? So the base class for all of the observers is this plugin base class. And as you can see, I defined multiple methods. These multiple methods, as you can see, they are not abstract, they are already implemented. And why I did that? As you can see, they are marked as virtual, which means that you can override them inside the child classes, inside the actual implementation of the plugins. However, most of the plugins will need just to execute logic in one of the places, right? In the plugin execution engine, as you will see in a minute, it's very simple class. It will just for each of the plugins and execute their methods. And even if you haven't, in order to simplify the implementation of the actual plugins, I don't want every time to, implement absolute classes and they to be empty. Instead of that, I just provided here empty-bodied methods that can be overridden if needed. Otherwise, they will do nothing. And I created those methods that basically say, this will be executed before the class initialize. This will be executed after the test class initialize. Before the test initialize, after the test initialize. Before the test cleanup, after the test cleanup. That's it, very simple. And we provide some data like which is the test class, which is the test method. That's it. This is normal, reflection in C#. and we have one enumeration for specifying whether the test passed or failed. Then the plugin execution engine, again, in this architecture, this is this class, which will be responsible for working with the plugins. It will contain methods for adding a plugin and removing a plugin, and for reaching basically the hash list of all plugins. Why hash list? Because we want, you can use a list or a hash list. For simplicity here, I change it to list, but if you use hash set, basically we'll have just, you'll be able to add a unique plugin just once. And this is usually what you want. You don't want to add a plugin twice. Or you will need some additional conditional checks. So my plugin execution engine, as you can see, it's static. And another thing is that it contains this list, static read-only list of plugins of the base class. So this means that I can put here any actual implementation of a plugin inside this list. I have two very simple methods called add and remove. They will add plugins and remove them from the list. And after that, I have similar signature of methods like my plugins. Now they are static. And as you can see, the only thing that these methods are doing is that we're for eaching all of the plugins inside the list and executing their methods. As I said, even if you haven't overridden them, most of the cases this will do nothing. It won't slow down or anything, but again, we're just for eaching them. That's it. Now, we need now to connect them. If you take a closer look, the second part is to actually create this base test class, right? And this base test class will be the central base class for our not only web tests, but also in the next module we're going to discuss how to create similar project but for mobile tests using Appium. So this will be the base class for the mobile test, for the web test, for the API tests, and for all different kinds. And this will allow you to reuse the plugin architecture between the different types of projects. So if we return to the project here now, inside this infrastructure, as I said, our framework can support multiple technologies, but right now we'll focus only on NUnit, but you can do the same for MS Test if you want, and even XUnit, but it depends. So for NUnit, I created this base test class. I mark it with test fixture. If you're not familiar with NUnit, you will find in the links below there is a whole playlist with very detailed explanations about NUnit, but this is my favorite test framework for .NET. So this is an abstract class called base test. This means you need to derive from it. We use the test context, which comes from NUnit, in order to get some information, for example, whether the test failed, the test name, etc. One-time setup is a specific attribute in NUnit that basically decorates a method that this method will be executed before, just once, before all of the tests. This is why it's called one-time. We're going to set up just the class. And this is why here I use my plugin execution engine. Since it's static, I call onBeforeTest class initialize, right? And now in my child classes or in my tests, I won't use this attribute. Instead, if I want to execute some logic inside the class initialize, now I'm going to override this protected method called virtual class initialize, right? The reason for that is that I want to have just one core one-time setup. And in order to, use my plugin execution engine, here at this point, this will execute, this will for each all of the plugins and execute their onBeforeTest class initialize if they overridden them, right? then it will execute my logic if I have overridden the class initialize, and then we're going to execute the on after test class initialize. I did the same for the setup. This is the test initialize, right? This method will be executed before each test. We have some .NET specific logic for getting, if the test failed, it will populate this throw exception, because in NUnit there isn't another way for getting the actual exception of why the test failed. But sometimes we might need this information inside the plugins, and this is why I want to capture that, and after that provided it here to the after test cleanup events, so that we can do something with it. For example, we can send it to the cloud, send it to the test report portals, etc. But basically I'm doing the same thing. I'm calling my execution engine, and it's on before test initialize, which will again for each all of the plugins here. Then if I want actually to execute my custom logic inside my test, I'm going to override this empty method now, which is protected virtual, which is test initialize. I won't use the attributes. And then I'm executing the on after test initialize. And we're doing the same thing for the teardown. Again, plugin engine, empty test cleanup, on after test cleanup, that's it. And we're doing the same thing for the class cleanup. Also, you will notice that I have one additional empty method called configure. This will be the place where all of the child classes will define which plugins need to be added here. So if we take a closer look to how our tests will look now, if I open them, you will notice that right now I'm not using directly here the base test, right? I'm using the web test. This web test is placed here inside core NUnit, and this web test will derive from this base test. As I said, the base test will be the parent class for the web test class, for the mobile test, etc. And this is how we are going to reuse the plugin architecture. So on my web test, I have access to the application class, which, if you remember, it holds references to the driver adapters and working with page objects. And I'm overriding the configure method, where I called my plugin execution engine .add plugin, and I added this new plugin that in a minute I'm going to explain how it works. And after that, we are going to explain what this component plugin execution engine is. It's a similar implementation, but allowing us to extend a little bit the web components. Where, as I said, I have created a similar plugin architecture, but allowing us to, for example, execute logic when a particular element was located or not. Again, if you use hash set, probably you don't need this if condition, but for now, since I rewrote that with list, we need to use that every time. And only once we'll add the plugin, and after that, this will start working. Now, let's explain how this local execution attribute works in this new plugin based on our plugin architecture. If we don't have it, we need to use every time our driver factory to call every time in every class, in every test unit, this start method, where I need to pick the browser version, and this will initialize everything. And of course, in the teardown, every time I need to dispose it, right? And this is a problem, because especially when you want to reuse the test later in the cloud and maybe change the browser, etc., it's too much code duplication. And I really like another approach where when we use these attributes, local execution, I can really quickly change from this enumeration the type of the browser. Also, we have a lifecycle where we can restart the browser just on failure or every time, or we can reuse it locally if it's already started, and this will optimize the execution time, which is really great. I mean, here this can run the test twice as fast locally. However, yeah, and later maybe we can extend up later when we talk about responsive design testing. We can instruct here through the local with this attribute, for example, changing the resolution, changing the size of the browser, and adding other stuff. Also, this attribute allows us to not only to place it on top of the class, but also we can override this behavior and, for example, say this particular test should be executed against Firefox, right? And this works out of the box. The way this works is, again, we're going to use the plugin classes that we defined in our core right here. Again, let me remind you, this is inside PowerSwide.core project, inside the plugins namespace. And inside my web project, I created this plugins folder right here. And we have browser execution. We have the browser enumeration. We have the browser configuration that we used the last time that accepts lifecycle and execution type. We're going to use that more, especially when in the video about responsive testing inside this module. We're going to upgrade the solution and be able to run it inside the grid, inside the Lambda test. So as I said later, we're going to upgrade it further. But the core logic is happening inside this browser lifecycle plugin right here. And also we have this attribute. This attribute is a class where we use this attribute usage, where first you need to mention here where you can put this attribute. We can put it on top of a class and on top of a method. Also, we instruct that we can inherit it, because later we're going to again create additional attributes, for example, for quality execution, grid execution, etc. And you cannot put multiple of them, that's it. And we have a very simple constructor here that, again, we just provide the browser and the lifecycle, and then based on it, we initialize the browser configuration class. So inside the browser lifecycle plugin, here it is, we derive here from the base plugin, this is our base observer. If we return to the diagram, the plugin class is here. It defines all the empty methods that you can override. And then we'll have different plugins, not only controlling the browser lifecycle, but many more that will override just a specific point that they want to execute logic inside. In this particular case, we are going to execute logic inside on before test initialize and maybe on after test cleanup, where we're going to close the browser. And again, we're not going to override all of the methods, right? We're going just to execute logic here and here. That's it. In the point when we execute logic before the original test initialize. Why here? Because many often inside the class initialize and test initialize, you want to, for example, navigate to a page, find elements, etc. This is why before the test initialize, we need to start the browser. We have a method called getConfiguration. Here, inside these three methods, we use C# reflection. This C# reflection allows us to get from a specific type or a specific method to get its attributes. And after that, we check, do we have a method attribute? If yes, then please get its browser configuration. Or otherwise, get the class. Later, we're going to upgrade that when we discuss the module about configuration files. Here, we're going to add additional logic for reading default values from a JSON file. And we'll have different JSON files for the different test environments. So this get browser configuration basically gets the information out of the attribute and initialize this current browser configuration object. After that, we have should restart. And here we have some logic based on the life cycle enumeration, whether we need to restart it. If it's not set, of course, we need to restart it, etc. And in the restart browser, it's obvious what to do. We close the browser, we dispose it, and then right now we have only implementation for local execution. As I said, later when we implement this execution inside the grid and inside the cloud, inside the Lambda test, we are going to create additional methods here inside the driver factory. But for now, we're just calling the static driver factory to start the browser. And as you can guess, inside the on after test cleanup, we're doing a very similar thing. We're shutting down the browser if we need to restart every time, and depending whether we need to restart it on failure, and if the outcome of the test is failed. That's it. And later, inside our tests, the only thing that we need to do is we need to comment here the driver start factory. I'm going to comment here the tear down. I already derived from the web test and put this local execution for run. And now, if I run here this particular test, it will use now our plugin architecture in this execution browser plugin to run the tests. It will restart every time the browser, etc. Also, right now, I have added 2 more plugins that in a minute I'm going to explain that are extending the particular web components. As you can see, without the driver factory now, out of the box, using the plugin, this started my browser. It will navigate to the website. As you can see, the highlight now is working. In a minute, I'm going to explain how this works. It's a very similar, we have a similar execution engine and a base class for the plugins, but they basically give you another point. That's it. And now we have a green test. So as I said, let's now look into these additional plugins, this web component plugin execution engine. I wanted to create 2 plugins for highlighting and for scrolling into view, because sometimes, for example, especially in this case where we purchase products, if you try to check accept terms, this won't work unless you scroll down. And this is especially useful when you have video recording of your test, because you will see exactly where the action is happening, right? Otherwise, you will just see the visible part of the browser. WebDriver is not scrolling automatically, which is normal. I mean, this is not a drawback of the framework. This is why we need frameworks. So, where I put that? Well, inside our plugins folder now, I have, as you can see, a folder called components. And inside this components folder right here, I created another base class called WebComponentPlugin. The WebComponent plugin is very simple. Again, it contains 2 virtual methods that have an empty body. Your plugins, if they override that, if they don't override that, nothing will happen, nothing will fail. But as you can see, the method is called onComponentFound. As you can guess, this will be executed exactly when the lazy loading is triggered of the web component. Exactly when we found the native web element, this will be triggered. And all the plugins will be for each of these web component plugins. We have a similar static class called Web Component Plugin Execution Engine that is responsible for holding a reference, a list, a hash set to all of the web component plugins. You have again 2 methods, add and remove plugin, but this time you accept the observer for the web component plugins. And we have 2 methods where we just for each this list, that's it. The place where I execute that, instead of doing that in the base test, as you can guess, we are doing that in the base class for all the web components. If you watch the previous video, this is the adapter, the web component adapter, this base class for all of the web components, this web component class. And again, we don't have a list to plugins. We just use the static web component plugin execution engine. The only place where I use it is inside our wrapped element. If you remember, we implement lazy loading, which means even if you create the plugin, even if you create the specific web component checkbox button, at this particular moment, you're not going to search for it inside the browser or inside another element, but instead, you're going to trigger this logic only when you perform a particular action, click, typing text, hovering, etc. And this is why, after I found my wrapped element, this is the place where I'm going to for each and execute the logic of all of my web component plugins that have implemented this onComponentFound method. And I already did that. I created two additional plugins here, the highlight element plugin and the scroll into view plugin. They both use JavaScript. This scroll into view plugin, as you can see, it derives again from this web component plugin, the base class. This is the base class, the base observer for this current implementation of the web component observers. And I overrided only the onComponentFound method. We just execute a simple script that it's using JavaScript to scroll down to this particular iWeb element. That's it. That's only thing. And since I don't want again to put that and every time change my base class for web components, I did that inside the plugin, this loosely coupled architecture again. And again, I want to add later the highlighting. That's fine. I'm not going to edit the web component base class because it can introduce regression and many other things. And I don't want to make it much more complex than it is. It's already very complex. So this highlight plugin again overrides onComponentFound. And we have some, if you watch some of my previous Java videos or others, we use this multiple times to do that. Using the getCSS, getValue, etc., we get the original background colors, etc. of everything. And we change them to yellow and red, the outline. And then we use native JavaScript to return it back to the original background and color after 500 milliseconds. And we just go execute script, that's it. And this will happen really fast and it will simulate this highlighting, which is really helpful for, especially when you watch videos, right? So this is how the plugin architecture works. So we already checked now how the browser execution plugin works and the web components. Now let's finalize our module with discussing some other customizations based on the stuff that we built the last time. I'm going to show you how to create a custom locator, custom weight strategy, and new components. Again, this is the real power to use a framework, not just a simple library. And I did that outside of our framework repo. Instead, I'm going to do that in our repo where our tests are, and we used our framework as a submodule. And this is the usual approach, right? Your other second team will just use the framework as a submodule, and they won't, if they want something custom, they won't push it back to the framework. Instead, if it's just something custom for them, they're going to add it to their customization project here. Now, imagine that we want a custom locator. What is this custom locator? I called it find by label, label find strategy. What is this label find strategy? I use this very often in many of our projects, especially in places where we don't have very good ideas or, locators are changing many times. We use actually these labels to find the inputs here. The way we do that is we use XPath access. There is an awesome article on the Lambda test blog about XPath. I suggest you to check it out. And what I do here, I can type the label. As you can see, the label is on top of the input. So first we find the label, and then we use following sibling, finding the div, and then the input. But again, this layout here for HTML elements, it's absolutely the same for all the inputs, for all the selects, etc. So we can reuse that. For example, if I change it to last name, as you can see, we found the next, and we can do the same for the email and the phone. So it makes sense to have such a fine strategy. The way I did that is, again, I created a namespace called locators inside my customizations project. Our demo system test, it reference again our customizations. And now I added here, I derived from the base class find strategy, and I overrided this convert method where, using string interpolation, we are just providing the value that we're supplying to the constructor. Of course, we need to create some extensions to ease our job instead of using find and then new find strategy, etc. In order to do that, I created inside the services namespace a class called driver-adapter extensions. And as you know, extension methods, they allow you to create these static methods, and they will be part of the driver later as they were, I don't know, written directly in the class. So I created this find label. Basically, this is absolute copy of all of the rest of the methods that are part of the original framework. You don't need, like here, if you go to find, you will see that they're exactly matching these methods here, right? It's very similar, but instead of calling it find by ID, I called it find by label. And we use the same signature with generics. So the only thing is that now, in order this to be an extension method, this needs to be static. You need to put them inside the static class, and also they need to mention here what they're extending. In our case, this will be the element find service. When you call element find service, after that they will appear as original methods of this interface. And here I'm calling my driver adapter dot find component, and then I provide the label strategy. I did that for find by label and find all by label. Also, imagine that sometimes you want to add some methods that are missing in the framework driver adapters. I missed the last time on purpose to implement working with alerts. And this is why here as an extension method, again, part of this driver adapter extensions, I added these two extension methods for handling alerts, providing some action, working with them. Again, this exact implementation, it's not so important, but the important part is that you can add additional methods to the services without modifying the framework. Of course, in languages like Java, where you don't have extension methods out of the box, you have them with some extensions like Lombok and others. But still, if you want to do that, you will need to basically create a child class out of the adapter. But here, we have extension methods. You have extension methods in TypeScript as well. So this is a very popular approach, and we can add these additional methods to our driver adapter. Or to particular interface, it will be up to you. Maybe you can add them to the iBrowserAdapter. It will be up to you. And when we open now the tests here inside the framework, it will be really important that if you want to use the extensions, you will need to provide an ATA using to this particular namespace. Otherwise, you won't see the extension methods. This is why I'm going to add the using to this Polaris White web services, And now, if I use here app.elements, we can type app by label. Do you see? And there is a star and there is this sign here that means that this is an extension method. It's not originally from the original implementation, but it's an extension method, which is excellent. And by the way, I did the same. I created another class for web component find extensions. As you know, we can search inside components, not only inside the browser. For example, you can search for other elements inside a div, big div, or inside a table. So here, instead of extending here the 𝑖_element find service, we are just extending the T component, implementing the same thing. I did something very similar for adding a custom wait strategy. Imagine that you want to wait a particular value to appear inside your HTML element. And this is exactly what I did. This is why this is called toValue containing wait strategy. It will wait when you find the element here. It will wait for the value attribute to contain a particular value. Again, it's relatively basically copy-pasted one of the original wait strategies, but again, it's outside of the framework itself. And in order to allow you to have this syntax about using fluent syntax to adding these strategies to the web component that will wait for them before returning the element, we basically I created this new class with extension methods called WebComponentAdapter, and basically we create the wait strategy, then we call the ensure state and provide the wait strategy inside. That's it. And now in the checkout, again, before typing something, for example, inside the first input, we have access to value contains, again, is displayed as an extension method. Again, all of those are outside of our original framework. And imagine that, lastly, I want to show you how to add custom components. Imagine that right now, if we look closer in our web framework, we don't have components for phone and for search, for this HTML5 HTML tags. And similar to the ML, we want to add such an implementation together with all of the validate methods that come with it. Again, where to check how they work, you can open the MDN web docs, the Mozilla website. Here we have the input. This is a specific input for working with phone numbers. They have, if you take a closer look, they have max length, min length, how long can be the phone, or a minimum length. This triggers some validations, front-end validations, so it's important to verify that. The same thing goes for the search. For maybe you can implement color as well. Usually they work with setting the value attribute. So the thing that I did, again, they're not part of the original framework. Instead, inside my customizations project, right here, I created a new namespace called components. And I added them. I added these two components. They will work out of the box using the find methods, find by label, find by ID, etc. This is why we created these different components. Our framework is lacking of some of the interfaces for them. If you remember, we use these interfaces for allowing these validate methods. They are special assertions where we will wait for a particular condition to happen. For example, we wait for the phone to be disabled or the phone to have a particular value, etc. But again, we derive from the web component. And we have many of these placeholders. Again, I did this research and I decided that we have get phone, set phone. As you can see, we are not using regular send keys, but instead we just set the value attribute because this is HTML5 control. If you need to call some of the base methods and define them as public, we just use the new keyword in C# and then call base hover to reuse this protected method. And after that, we have pretty new properties unique for this phone and search, which is autocomplete. Again, we use get attribute. Instead of doing that every time, we do that here because it makes sense to validate them, whether it's required, whether it's read-only. This might be an acceptance criteria for you. And it's very useful to have them here instead of every time, using get attribute. And I added this max length and min length. As you can see, we are parsing them, we are returning them as integer, we have the size, and I mark all of them as virtual so that if you want to change their behavior later in a child class, you can do that. I did the same thing for the search. Again, we are lacking some of the contracts from some of the interfaces. This is why I added them here inside my customization project. I created these very simple interfaces for holding an integer, a public property to the max length, to the min length, to getting the phone, etc. And what is this giving us? Well, it gives us the possibility to create extension methods for validating all of them. For example, we have an extension method to this interface 𝐼ComponentSearch, and we're calling the validate method that, will wait for this particular condition to happen, and we'll wait for search results to be equal to the particular value. Otherwise, this prettified message will be displayed together with the URL. And I did the same for creating similar validate methods, extension methods for validate max length, etc. And again, they are not part of the framework, but you will be able to use them as regular methods part of the framework. And one last thing, if you want to add methods that are missing in existing elements, you have two approaches. One of them is to use extension methods. That's pretty fine. You just create a static class called email extensions if you are going to extend the email. Our email actually was lacking of this max length, min length because we added them now. And it's pretty simple. We're just extending the original email component, which is part of the framework here, part of the Polaris White Web. Yeah, we're implementing them the same way I did before. They're actually here, email extensions. Again, in order to use them, I put them, in order to ease the usage, I put them in the general Polaris White Web namespace. Another approach is to just not define it as partial, but to create a child class out of the original component, and then you can just override some of the emails, some of the methods. Why here? I just overrided this method setEmail. Instead of using send keys and clear, I used another approach for example, setting the value attribute. This is a very popular approach for example, many people are changing the behavior of how buttons are clicked. Instead of using the original click, they use JavaScript, and that's fine. You can just create a child class out of the button and then change how the click is working. That's fine. Yeah, we covered a lot of things. So we discussed how to use our framework as a Git submodule. We discussed what the Git submodules are. We discussed in many details the observer design pattern and creating this plugin architecture. And at the end, we had a short overview about all of the possibilities how you can customize the framework, creating custom locators, wait strategies, creating many extension methods to the driver adapter and web components. We created some custom brand new web components, and you saw the real power of the framework to be able to customize it and create plugins for it. In the next module out of our course about building advanced test automation frameworks, we are going to build and create the next project responsible for automating mobile applications. We are going to build these core mobile components. Thank you for watching. If you have any questions, put them in the comments below. Also, don't forget to check the Lambda test book and get your free Lambda test certification about many of the technologies mentioned. Thank you for watching and see you in the next module.